All right, so you may wonder how charts and graphs might apply to you. Well, charts and graphs are literally everywhere. We can find them in newspapers and magazines, all over social media, Twitter, wherever you look. So they're also found in textbooks. And then if you are in an AP class, or if you're planning on taking the PSAT or SAT, which means that you're almost every student at this school, um, they're all over the PSAT and SAT. So let's take a look at what we're going to learn today about charts and graphs. So first thing that you need to know, our goals for today, I'm going to introduce you to some different types of charts and graphs. I'm going to talk to you a little bit about how to read the images, and then I'm going to talk to you about how we would use them to answer questions or to support evidence in writing in our own writing. So first of all, a graph is information in a picture. So it is a way that we summarize information, and it shows connections between numbers and amounts and concepts. So the most common types of graphs are lines, bars, circles, or they have pictures that show information. So our first graph we're going to look at are line graphs. And line graphs are graphs that typically show change over time and sometimes show the connection between two or more things. So they can show trends that are happening in the world around us and how things might be changing. So let's take a look at an example line graph. So if you take a look at this line graph right here, the first thing you want to do is read the title. So when we look up here, it says the seasonal nature of tourism. And then it says breakdown of total overnight stays in tourism establishments by percent. All right, so if you take a look at the left-hand column, the vertical axis right here on the line graph, it shows you the percent, 5% to 25% of overnight stays establishments. And then down here, the horizontal shows you another grouping of information. So, and that grouping of information is months of the year. So as you will see, in January, the number of percentage of overnight stays is the lowest. And in August, September, mid-August, it's the highest. Now, what does this information tell us? If you look down here, we see information, the key of what these different lines are. So the solid blue line represents Spain in 1990, and the dotted blue line represents Spain in 2013. And you can see that there are not a lot of changes over time in those 23 years difference. If you take a look at Italy, it shows the exact same story. So Italy seems like it gets a lot more visitors than Spain does over this same amount of time, but it follows the same pattern. And so that's one of the things you always want to look for in reading charts and graphs are patterns or differences in patterns. So let's take a look at the next type of graph. So that's a line graph. Sometimes it's a single line, sometimes it's multiple lines. This shows you multiple lines and usually has different colors to represent different things. All right, bar graphs. So bar graphs use columns to show information, unlike lines. So bar graphs have two labels. So let's take a look at our first bar graph. So this is bar graph again. Whenever we look at a graph, we're going to look at the title first, GPA by athlete status and gender. And this was taken from a college university information about GPAs of freshmen college students who were either athletes, recruited, or walk-on, or non-athletes, and trying to determine what their GPA status was. So this graph, a bar graph, just like the line graph, has information on the vertical and information on the horizontal axis. So if we look here, the GPA range is from 2.6 to 3.3. All right, so the bars show you not only what the average GPA was of those people, but it also shows you right down here the number of people that fill up that graph right there. So if we look at this particular survey that was done, we will see that there are more female non-athletes than there are male, because the total number here is different. We'll also show that non-athlete females have a higher GPA than non-athlete males. In fact, all females have a higher GPA in college than males, regardless of whether they are athletes or not. But then you can also see the difference between recruited athletes and walk-on athletes. You'll see that the walk-on athletes' GPA is almost identical in the female category as the non-athlete, whereas the recruited athletes are lower in both gender categories. Okay, so simple bar graphs can be used to show percentages, but more complex bar graphs compare data. So let's look at this next graph. This is a graph from the Wall Street Journal, and it compares women's pay to men's pay. So this is a horizontal bar graph as opposed to a vertical bar graph like the last one we were looking at, but you read it the same way. Instead of having information here, though, the percentages are given in each of the graph categories. So you have three different things to compare. These are all women. So you've got this lighter green represents women 25 to 34 years. This is 45 to 54, and this is all women. So it's the combined of those two, right? So what might we infer from this chart? So what I noticed right away is that women who are between 25 and 34 years of age in all years from 1980 to 2006 made more than women who were ages 45 to 54. So that's a pattern. And I want to start thinking about, what does that pattern mean? What kind of conclusions could I draw? So I could draw the conclusions that this information is because many women leave the workforce in order to take care of children, but I don't know that for sure. That's kind of making an assumption. But you might also notice that from top to bottom, there is a trend until we get to 2005, 2006, but that's only 1 year difference, right? As opposed to these, which are 5-year differences. So you can see that there is a trend that the percentage of women's pay compared to men is getting better over time. Okay, the next type of graph we're going to talk about is pie graphs. In some cases, these are referred to as circle graphs, but most of the time as pie graphs because they look like a pie. So let's take a look at our first pie graph. So this graph shows you how a whole is divided into parts. So if we look up here, again, always look at the title. So this is September 2009, and this is about volunteer activities for volunteers in a Maine organization. So each pie is labeled with a particular percentage, and you will see that the highest percentage of volunteer activities are religious. But let's say that you were deciding to write a paper about how Americans volunteer spend their time, and you wanted to know how people participated in environmental volunteerism. So we can take a look at environmental or animal care, and this is that tiny little pie in 2009 in September. Only 2.2% of the people surveyed took part in environmental or animal care. But then if we look at that label one more time, we know that it wasn't even 2.2% that volunteered for environmental activities, because this includes both environmental or animal care. So sometimes you want to look to see when we see multiple things taking up a pie, like again here, hospital or other health, or civic, political, professional, or international. That's a lot of stuff combined that make up that little pie right there. Okay. The next type of image we're going to look at are maps. So there's a whole bunch of different kinds of maps. So political maps show how people are divided across the world's surface. They're the maps that show us, these are the different states, these are the different countries, these are the different borders and boundaries. There are a whole bunch of other maps that show how people are distributed, or how a different quality is distributed. Let's look at one of those distribution maps. So this is about obesity rates, and this is a very interesting graphic that you would have to read. So up here, we see that's obesity rates among children aged 10 to 17 in 2007, and then down here at the bottom, it describes to you how those obesity rates were classified, and it gives you the source. All of those maps so far, or all those graphs so far, have told us the source. The way we read this, we also want to look at the key here. So this is blue states are where obesity increased since 2003 in those 4 years, and gray states are where obesity decreased in 2003. But the percentages on each state are not about the percentage of how much they decrease, but the obesity rates. So let's take a look at Wisconsin and Illinois, since they're right next to each other and a pretty good contrast. So if you look at Wisconsin, the obesity rate in Wisconsin in 2007 was 13.1%, but that percentage had decreased since 2003. Now we look at Illinois, 20.7%, and that obesity rate in children ages 10 to 17 increased since 2003. So, and then if you want to compare that to 20.7 to all the other states, you will see that Illinois is the third most obese state, tied with Louisiana in 2007. Kind of gives you some information. All right. The last type of graph that we're going to talk about today are data tables. I honestly think that they're the least interesting type of graph, but don't tell anyone else. So one of the reasons that I think that they're the least interesting is that they're not particularly fun to look at. So they can be dull, and all this data can be hard to read in paragraphs. So we use tables to help us scan. And one of the reasons we use these tables is because it helps us look for patterns again. So let's take a look at this table and see what this is. So this is information from Vanderbilt University that shows entry-level and mid-career earnings by majors. How would you use this information? So if you are thinking about what you want to major in, you can look down here. All of this is organized in alphabetical order. And that's one thing to know. You could organize this by starting median salary or mid-career salary, starting salary or mid-career salary, or you could organize it by ratio. And then it would change the order of which all those things were on here. Let's say if you were motivated only by earnings, check out undergraduate major in math. So starting salary is not the highest starting salary. If we want to look for the highest starting salary, mechanical engineering. But if you start at 45.4 with a salary in math, your ratio increases rapidly, 2.04 ratio. So by the time you're in mid-career, you're making $92,000. You've almost caught up to mechanical engineering. On the other hand, sociology is the lowest ratio earning and one of the lowest starting salaries, the lowest starting salary, and the lowest mid-career salary. So you might want to consider which school you want to go to that offers you the best scholarships or cheapest tuition if you want to major in psychology, so you're not going to be plunged into debt. So that's how we read those charts and graphs. And one of the things you want to look for are things that stand out or differences. So this, for example, is a big thing to take a look at. And you want to look at what's the lowest. Here we go. Information technology, IT, is our lowest. And I usually look at those right away. I'll circle the lowest and the highest in each of those categories when I'm glancing at a chart or a graph, because I know I'm probably going to have to answer questions about that. Okay, so overall, what I want you to know is that reading charts and graphs provides us with a different worldview than we might normally have. We might see things slightly differently. We might take a look at the world in a way that helps clarify information that might be confusing to us otherwise and makes it easy to stand out. And most importantly, understanding how to read charts and graphs gives us information about ourselves and how to plan the future and maybe what sort of things we want to prevent in the future.